Today we're learning about limiting reagents, which is a reagent that limits or determines the amount of product that can be formed. It's always going to be the one with the least number of moles. It's not necessarily going to be the one with the least number of grams or mass. So what you'll have to do is you'll have to basically try to work the problem for each reactant and then take the smaller of the two answers. If my sandwich always uses 2 pieces of bread, 4 pieces of meat, 2 pieces of cheese, 3 pieces of bacon, and 2 ounces of special sauce. Now, if I have 20 pieces of bread, 32 pieces of meat, 20 pieces of cheese, 21 pieces of bacon, and 1 quart of special sauce, how many sandwiches can I make? You may be helpful to know that there are 32 ounces in 1 quart. Okay, so that may help you out. You may have figured out that there's 20 bread slices and you're going to use 2 per sandwich, so that gives you 10 sandwiches. 32 meat slices will yield you 8 sandwiches because I'm using 4 of them per sandwich. 21 bacon slices will actually only give me 7 sandwiches because I'm using 3 per sandwich. 20 slices of cheese will give me 10 sandwiches. And then 32 ounces of special sauce will give me 16 sandwiches. So the limiting reactant is this one. It is the one that is the smallest number. Okay? Easy. All right? Now, this is just a sandwich example, but this is actually really close to the moles. All right? Because if you think of these are all objects on the left: bread, meat, bacon, cheese, and special sauce. They're all objects. Well, that's what a mole is. And the one that's used is going to be the coefficient, all right, in your equation. And this is the number of moles available, all right? So you can actually you can do this quickly whenever you approach a problem if you take the number of moles available and you divide it by the coefficient. Now, that is a mental way to approach these problems, but there's also a foolproof way to do it by using a little bit of stoichiometry. I had x plus 2y gives me xy 2, all right? There's 2 y's and 1 x per every molecule right here. This is, and x's are squares, y's are circles, and then my final molecule is a square with 2 circles on the side. So if this is what it looks like before the reaction, what's it going to look like after the reaction? Go ahead and pause the video and see if you can figure it out. Well, did you just take squares and add 2 circles to the side of them? Because that's what you should have done. You should have done that. Keep the same number of squares. There's 3 squares here. There's 3 squares here. All right, and keep the same number of circles on the right side, and you end up with extra circles over here. You see these 2 circles, this one and this one? That means that I have an excess reactant, and that excess reactant is my circle, or my y, right here, my element y. So my limiting reactant was my element x, okay? It was the one I ran out of. The way we mathematically show this is if we have a problem like this, how many moles of iron oxide can be produced by allowing 1 mole of iron sulfide, 2 moles of water, and 3 moles of O2 to react? Well, so what we have to do is take this equation, and we have given a number of moles. And now if I tell you that water is my limiting reactant, you can figure that out by looking at the different numbers of moles, but the limiting reactant is water. If you just take my 2 moles of water right here, and that's the information that you're going to start with. You can only do a stoichiometric calculation off of your limiting reactant, okay? So then I do my mole ratio, and I can find the number of moles that are going to be produced. Right, number of moles of iron oxide produced. Okay, Now, the way I figured this out was I took my number of moles right here and I divided it by my coefficient. Okay, so here I divided this by my coefficient, and here I divided this by my coefficient. Well, this 1/2 is 1/2, or 0.5. Now 2 divided by 6 is going to be 1/3, or 0.33. And then 3 divided by 3 is going to be 1. Hey, which one's the smallest one? That would be this one. That's why it's the limiting reactant. All right, everybody getting it? All right, and one last one. There is another option you can do if that is still boiling your brain. You can use, just do the 4-step process twice. And that way, and just choose the smallest answer. For example, if we had 17 grams of ammonia were reacted with 32 grams of oxygen in the following reaction, how many grams of NO would be formed? So, if you started with this given information, I have my 17 grams and my 32 grams here. Notice, watch out. I gave you 2 reactants and I gave you 2 masses. This is a limiting reactant problem. If you get something like this that has 2 masses for 2 reactants, one of them is going to be limiting and you have to figure out which one it is. Sometimes problems won't automatically tell you that they're a limiting reactant problem, so be careful. Now I want to know my grams of NO. So what I have to do is take my grams, do my normal stoichiometry, starting with my ammonia first, and we're going to see how many grams of NO that would yield. And then I'm going to do my stoichiometry with my other reactant right here, my grams of O2, and see how many grams of NO that will yield. Well, the smallest answer is going to be the right answer, okay? This is the limiting reactant. This is not the limiting reactant. Sorry, NO is not the limiting reactant. This is the limiting reactant, okay? Because remember, reactants are on the left side of the equation. So be careful. Don't just think that this one at the end is the limiting reactant. Now, there's going to be a couple of extra things on your homework that are going to ask you some questions. It's going to ask you how many moles, or the objects, of an excess reagent are left. So we're going to go back to the sandwich example, and I'm going to try to explain this. So if 7 sandwiches was my limiting, right? So this is my limiting reactant here. Well, that means that I used all 7 sandwiches, and those are down to 0. Okay? Now, I used all 7 sandwiches here. I used all 7 sandwiches, but I can still make 1 sandwich, right? 1 sandwich left of material. And then here, I can have 3 sandwiches left of material. All I'm doing is taking this number and subtracting it by 7. And then 10 becomes a 3, and then 16 becomes a 9 sandwiches, right? Well, now I'm going to work backwards, and I'm actually just going to multiply by by how many it would take to be used. So if I multiply by this, I would have 6 moles, or 6 slices of bread left. Okay? And then here I had 1 sandwich left over, and I multiply it by this number, 4. So I would have 4 meat left over. Okay? And then here, this one was all gone, so it's all out of here. 3 times 2 is going to be 6 cheeses. And then 9 times 2 is going to be 18 ounces left. Okay, so you can calculate how many are left over. I won't show you how to do that in your homework. I want to make it a little bit challenging, but it's basically on the same example. You're going to actually have to subtract the number of moles used, and then you're going to have to multiply it by that coefficient. All right. I want y'all to have a good day. Bye-bye.